This example asks us to find the derivatives, and part A gives us the derivative of the quantity x to the 8 plus 12x to the 5th minus 4x to the 4th plus 10x cubed minus 6x plus 5. And we just introduced all these rules of differentiation, and those will become second nature, right? So here's how that works. The sum rule tells us that this derivative is going to go through to each term. So really we're just going to take the derivative of each term here, right? So it's very intuitive. That's kind of what we'd expect to happen. So we don't have to go around stating by the sum rule, we just essentially just do it. Also, the constant multiple rule tells us that the constant is just going to hang out in the front of each of these derivatives. So the d by dx is going to go inside the constants and just hit these x to the 8th, x to the 5th, x to the 4th, etc. So that's really what we're taking the derivative of. So really what we have is the power rule. And the power rule tells us that the derivative of x to the n is equal to n times x to the power of n minus 1. So that one you want to deeply internalize because we'll use it so often. So let's do it on this example. So the power rule gives us x to the 8 becomes 8x to the 7th, right? For 12x to the 5th, that 5 comes down, multiplies with the 12 to give us plus 60. X to the 5 minus 1 is 4, right? Minus, now the 4 comes down to combine with that 4 that's already there, so minus 16. X to the 4 minus 1 is 3. 3 comes down, combines with the 10, plus 30. X to the 3 minus 1 is 2. Minus 6. Okay, minus 6. Well, what happened to the x? Well, the 1, it was x to the 1. The 1 came down, and then x to the 1 minus 1 is 0. And then, we're left with just minus 6. And then the derivative of a constant, remember the derivative of a constant rule, I think we call it the constant rule, that just goes to 0, right? Derivative of a constant is 0, so this result is our final derivative. 8x to the 7th plus 60x to the 4th minus 16x cubed plus 30x squared minus 6. Well, that wasn't so bad, but just imagine what it would have been like to find this derivative using the limit definition of the derivative. Right, we'd still be working in an hour from now, maybe 2 hours from now, but maybe not, but it certainly would take quite a while. Let's try part B. We have d by du of the quantity u cubed plus 1 times the quantity 2u squared minus 4u minus 1. Now, we don't have a product rule yet, but we'll get that soon. But for now, let's manually multiply these together and then take the derivative. So how about you try this? So try this out on your own, pause the video, multiply those together manually, and then see if you can take the derivative, and then we'll compare notes. Okay, first step here is to multiply these together. So I'll do a double distribute. So what we're really looking at here is the derivative with respect to u of, okay, well, multiplying that u cubed through to everything, I get 2u to the 5th minus 4u to the 4th minus u cubed. Okay, and now multiplying the plus 1 through to everything, plus 2u squared minus 4u minus 1. And now we have a nice polynomial. We can use a combination of all our differentiation rules that we've developed so far now to find this derivative. And we're essentially just applying the power rule. We're taking this exponent down, multiplying, subtracting 1. Take it down, multiply, subtract 1. Take it down, subtract 1. Take it down, multiply, subtract 1. On and on we go. It really just becomes second nature, and you won't even think about this soon here. So this becomes 10u to the 5 minus 1 is 4, minus 16u cubed minus 3u squared plus 4u to the 1, which I'll just write as u, minus 4, when it's just a single u hanging on, a single variable, you just write the constant in front, right? Because u to the 1 minus 1 is u to the 0. Anything to the 0 is simply 1. And then the constant drops off, right? That minus 1 goes away, and there is our final answer. That was super fast, and you'll get even faster at this. It'll be so fast, it'll be done in the blink of an eye. And just again, just to stress one more time how much faster this is than doing the limit definition of the derivative on this u.